Ahoy hoy, I am Planetwalk, and today I want you to pretend that I'm a flat earther, because today I'm going to be pretending that the earth is flat. See, we all get to pretend today. How fun is that? Now, you may ask, wait, why are you pretending to be a flat earther? Isn't that dangerous? Couldn't you possibly suffer irreversible brain damage? To which I say, yeah, you're probably right, but I did take classes at the Flat Earth Community University, so I know a few ways in which to keep myself sane. So a lot of people are probably wondering, why are you pretending the earth is flat? We all know the earth is a globe. And the reason is, there's something that a lot of flat earthers ignore. They like to say that the earth is flat and stationary. However, we know that the earth is spinning.
But what we found is when we turned on that gyroscope, we found that we were picking up a drift. A 15-degree-per-hour drift.
Thanks, Bob. So yeah, the best way to explain that 15-degree-per-hour drift, whether the earth is flat or a globe, is if the earth is spinning, right? Well, flat earthers are unlikely to accept that, so I'm actually going to do what no flat earther has ever done, and make a good case for the flat earth to be spinning. So the first thing that we're going to look at is we're going to look at the sun. Well, we're not actually going to look at the sun. Do not look at the sun, people. That is bad for your eyesight. So a lot of flat earthers say that the sun goes around the North Pole once every 24 hours. Never mind how it actually floats up in the sky and stays up there. Just don't worry about that. That's not what we're focusing on. We're being a flat earther, remember? Now, the issue that we're going to solve for flat earthers will be the seasons. You see, on the flat earth model, during the winter, the sun is close to the North Pole, and during the summer, it's further away. And before you say that I've got it mixed up, I live in the southern hemisphere plane. Now, when the sun is closer to the North Pole, the circuit that it makes around the North Pole will be shorter, whereas when it's further away, that circuit will be larger. However, on the flat earth model, it always does the circuit in 24 hours. Now, not a lot of flat earthers realize this, but this is a problem if you assume it's the sun that's moving instead of the earth. This is because of something called the conservation of momentum, which, to boil it down, means that an object's momentum will remain constant unless acted upon by a force. The conservation of momentum actually means that if you were to have your arms out like that and you were to pull them in, you would actually start spinning faster. So this means that if the sun is making a circuit around the North Pole, as it gets closer to the North Pole, it should be going faster, resulting in shorter days. But that's not what we see. The days remain 24 hours. And the solution to this, of course, is instead of the sun going around the North Pole, the Earth just spins around the North Pole. It's much better. It doesn't violate the conservation of momentum. And how do we get seasons? Well, it could just be that the sun moves back and forth like a pendulum. It's like dangling from a piece of string or something. And hey, that actually solves the problem of how the sun stays up in the sky. It's just dangling from the firmament by a piece of string. I've solved another one of the issues for you flat earthers. I'm doing this better than flat earthers. Now, there is an issue that flat earthers will point out. They will point out that the equator would have to be moving at 1,000 miles an hour. But that's not actually a problem. What flat earthers fail to realize is that the outward acceleration generated by centrifugal force would actually be very minuscule. It would only be 3 centimeters per second squared compared to Dropide's 9.8 meters per second squared. You'd barely even notice it. Sure, you may be on a slight tilt, but that tilt would be very minuscule indeed. And there's so many problems for flat earthers that this can solve. There are phenomena such as the Utvush effect and the Coriolis effect, which until now, flat earthers didn't have an answer for. You're welcome! And you want to know the kicker? As you travel further south, objects should start to weigh more. And I actually have evidence of that particular phenomena. So there is actually a video from Wolfie 6020, and I'll show you a bit of that, where as he goes further south, objects start weighing more, and as he goes further north, objects start weighing less. Check it out.
And I'm at 32 south latitude, which is Perth, and it's calibrated for 500 grams. you'll see how precise that is. It's to 1/100th of a gram, and it's showing it just nice and accurately there. So as I move to a different location, different latitude, it should now show me a different weight. So I'm now in Canberra, Australia, which is a latitude of 35 degrees 18 minutes south. So it's more than 3 degrees further south than Perth was, and that's just looking out over Canberra Airport. So let's see if we can actually measure that. There you go, it's 0.16 of a gram heavier at a further south latitude. So the last sample I want to do is here in Broome, Australia, which is 17 degrees 56 minutes south latitude. That's my current location. This weight should now appear less than 500 grams. So let's try it. Look at that, 499.44. So it's more than half a gram lighter because we're closer to the equator.
See, I told you, a flat spinning Earth works far better than a flat stationary Earth. But here's the thing. A spinning globe works better than both of them. Because on a spinning flat Earth, you still have to ignore evidence. You just have to ignore less evidence than if the Earth is flat and stationary. Because the experiment that Wolfie 6020 did was done in the southern hemisphere. If you go to the northern hemisphere, the results are completely opposite. As you get further south, objects weigh less, and as you get further north, objects weigh more. Plus there is that pendulum that the French philosopher made, Foucault's pendulum. I've been wearing that for too long. Anyway, that doesn't completely work even on a spinning flat Earth, but it works on a globe Earth. And nothing on a flat Earth can explain the fact that ships disappear bottom first over the horizon, the sun sets, yet we've got time zones, and there are 2 celestial poles which the stars rotate around. Now, flat earthers will never solve those problems. However, there are problems that I mentioned, which I also solved for a flat Earth, that flat earthers just won't solve either. You see, flat earthers don't seem to be interested in solving problems on a flat Earth model. They seem to be more interested in attacking the globe model. And if the globe is spinning, then the flat Earth can't be spinning, despite what the evidence may suggest. And if flat earthers can't take that basic step of going, okay, well, the evidence seems to show that the Earth is spinning, but it's still a flat Earth, then what hope do they have of solving all the other problems that the flat Earth has? And if you don't think that there's any evidence that the Earth is spinning, let me remind you, or let Bob remind you.
But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.